Jag pulls down one.
17 seconds from game 7 or from championship number 6.
Michael against Russell, 12 seconds. 11, 10. Jordan a drive, hangs, fires, yes! He scores! The Bulls lead 87-86 with 5 and 2/10 left. Oh my goodness!
He's unbelievable.
Oh my goodness!
That first part of the video had nothing to do with the lesson. That was just me homeschooling my son. It's how we're passing the time over here. That and growing quarantine mustaches. So I'm gonna work some problems up here. I know this is sexy. I need you to stay focused here though. All right, so the last thing we did, the last time I saw you, was simplifying rational expressions. And remember, all we did was factor them, and then we would cancel them. And then we did the multiplying and dividing part, but it was really kind of the same thing. You were still just factoring and canceling stuff. It just, were a couple little things that would change. The next lesson is adding and subtracting rational expressions, and it's a little trickier. Before we even start messing with rational expressions, I want to, do something that you should already know how to do, but let's make sure. If I told you to add those two fractions, presumably you would be able to do that without a calculator. Most of you would reach straight for the calculator, but let's pretend like we can't use a calculator. And you learned a long time ago that the only way you can add or subtract, for that matter, the only way you can add and subtract fractions is if you have a common denominator. Now, I know that most of you can probably find this common denominator in your head. We just want the smallest number that both of these numbers would divide into evenly. And most of you would say, I know that that is 12. But let's talk about why that's 12, or how you could figure out that that was 12 if you couldn't do it in your head. Because this process that we're going to do here, it's actually what we're going to use when we start doing the adding and subtracting the rationals. So look at these two denominators and let's factor them. And when I say factor, when we're talking about factoring a number, I mean like make a little factor tree or whatever. And so 4 is easy to do. 4, factors to just be 2 times 2. And so you could actually write 3/4 as 3 over 2 squared. Now you would never do this, but again, I'm making a point that's going to apply to the rational expressions. 6 is 2 times 3. And so we could write 1/6 as 1 over 2 times 3. All right, well, if you get it completely factored like that, then all you want to do is take every single different unique factor that you have. And so if I'm looking at all of these, I've got 2's and I've got 3's. That's it. So I'm going to have 2's and 3's in my common denominator. But if one of your factors has an exponent other than 1, you have to give it that exponent in the common denominator. In other words, you look at all the 2's and you say, all right, what's the biggest exponent? What's the highest exponent? In this case, it's 2 squared. So I need to give that a square. I look at the 3's. What's the highest exponent on the 3's? Was 3 to the first. So that's good the way it is. And that's where that 12 comes from. 2 squared is 4. 4 times 3 is 12. Now, the rest of this, you go through and you say, all right, well, I got to change these numerators now. And so you look at this denominator and you say, well, what is it missing to be that denominator? And the answer, it's missing the 3. It's got the 2 squared, it doesn't have the 3. So whatever it's missing, I'm going to multiply it to the existing numerator. So there's already a 3 there, that's that 3. And then I got to multiply it by the 3 that it was missing from the common denominator. Put a plus sign, that's that plus sign right there. Then I do this one. Well, this denominator has a 2 and a 3. So it's actually missing one of the 2's. So there's already a 1 there, and now I'm going to multiply it by that 2 that it was missing. And that's it. That's the whole thing. And that's exactly how we're going to do it with these rational expressions too. 3 times 3 would be 9. 9 plus 2 is 11. And we already know that this is 12. Your answer would be 11/12. Keep that in mind as we do these rational expressions, because you're going to see it's the same thing. Okay, so I've modified the notes a little bit. So hopefully you didn't print off the one that was on Canvas. I'm sorry if you did. I was looking at that, and I was actually about to make a video with those guided notes. And that I got that from another teacher, and what I realized as I was looking through it was that I was vastly superior to that other teacher, and that my notes that I come up with would, therefore also be vastly superior to those notes. So I changed the guided notes a little bit. There's no reason to go print it out. I mean, I'm gonna write everything. You'll see everything in the video. Might not be a terrible idea to write some stuff down, but you don't really need to print it out. But anyway, here are a couple of examples of adding and subtracting rational expressions. And these are like the easiest ones. This is the easy version. It gets a little crazier than this. So the reason I did these first is because I wanted to point out, and you'll see this occasionally, although not very often, but if the two fractions, the two rational expressions that you are adding, if they already have the same denominator, then you don't have to worry about it. That is the common denominator. So like in a problem like this, I'll say, all right, my common denominator is x minus 3. They both have that x minus 3 already. There's no reason to do anything to either numerator. And so that actually is the answer, and you're done. That's the whole thing. Same thing over here. It's a little trickier, I guess. My common denominator would be xy, because they both have xy. And then it would just be 5x squared plus 2. Be careful when you're subtracting rational expressions. Here's the minus sign that's right there, but then you're actually subtracting this whole thing, so you need some parentheses there. We want to express that whole thing is being subtracted. And so then, you can distribute that negative through there. That's going to be 5x squared minus 2x squared, so that's 3x squared. That is negative 3x, so that's plus 3x, and then plus 2 over xy. That's it. Okay, so you knew it was going to get uglier. But remember that very first example I did with those regular fractions. The reason I did that is because we are going to do these the exact same way. Remember, I took those denominators and I broke them down as much as I can. That's what I'm going to do to these denominators. When I say break them down, it doesn't mean factor them. So this first denominator right here, a squared minus a minus 20. I just need two numbers that would multiply to be negative 20 that would add to be negative 1. Well, that of course would be plus 4 minus 5. So this fraction over here, not even doing anything yet, just sort of changing the way it looks. But that and that are the same thing. Well, I can't factor a plus 4. That's completely factored. So this is really what I'm dealing with. And you remember, think about the example that I did with regular numbers, regular fractions. I took every single unique factor. Well, I've only got two unique factors here. I've got an a plus 4 and I've got an a minus 5. Then check the exponents, because if any of them have an exponent that is greater than 1, then that needs to be included in the common denominator as well. Well, that's not an issue here. I got a plus 4 to the first, a minus 5 to the first, a plus 4 to the first. So this is good. Nothing had an exponent bigger than 1 in any particular denominator. That's my common denominator. Now I go through and multiply that numerator by whatever part of that denominator it was missing. Well, this one's not missing anything. It's got both of them. So don't do anything to the a. It just stays a. Bring down that plus sign, bring down that 2. Over here, this one has the a plus 4, but it doesn't have the a minus 5. So I need to multiply that by a minus 5. Then I'm just gonna, do some simplifying up here. I'm gonna distribute that 2 through there. That would be 2a minus 10. So this is a plus 2a, which is 3a minus 10 over a plus 4, a minus 5. And that is it. That's the whole thing. This one over here is almost exactly the same. Again, before I even start doing anything, I'm going to factor these denominators. I'm not, doing anything with the numerator yet. Here, I need two numbers that would multiply to be -2, that would add to be 1. Well, that, of course, is +2 and -1. So this is x plus 2, x minus 1. This one is factored already, or it's prime. So that's what you're going to look at when you're doing this next part, which is the common denominator part. The unique factors, I only have 2 of them. I have an x plus 2, I have an x minus 1. Nothing was being squared or cubed or anything like that, so I don't have to do that in my common denominator. This one doesn't need anything. This one needs the x minus 1, so it would look like that. And then, if I distribute that -1 through there, that becomes -x plus 1. So this would actually be x minus x. So those are just going to cancel, and you're just going to be left with a 1 in the numerator. And so that is my answer. Nothing to it. Same thing here. This one looks a little bit weirder. It's going to for a second. I can't do any factoring to either one of those denominators. So this is the first time we've run into this, but that doesn't matter. I'm still following my rules. Once these are completely factored, which they are, then I'm going to list every single unique factor and give it the appropriate exponent. So here, the two things that were the two denominators, they just end up being multiplied together to be the common denominator. It's kind of like if you were to add 1/2 and 2/3. Well, if you were adding 1/2 to 2/3, your common denominator would just be 2 times 3, which is 6. Same thing here. All right, so this time, this denominator is missing the x minus 5. So that gets multiplied to the 2x plus 1. Over here, that one's missing the x plus 3. So we multiply x plus 4 by x plus 3. Now this one's a little bit annoying because now we got to do some FOIL, but that's okay. 2x times x would be 2x squared. Then this would be -10x plus 1x, that's minus 9x, minus 5, that's that first one. Then we got x squared plus 3x plus 4x, that would be plus 7x plus 12. Don't worry about multiplying the denominator out, we can just leave it like that. As a matter of fact, you want to leave it like that because there's a chance that we might get to the end and have more stuff cancel. I'm going to combine like terms here. 2x squared plus x squared is 3x squared. -9x plus 7x is -2x. And -5 plus 12 is 7 over x plus 3, x minus 5. So you don't need to do anything else with this unless there is the chance that something would cancel. Like if we can factor that numerator and cause, one of these factors in the denominator to cancel, then we want to do that. But we can just do a quick check without even writing anything. If I were going to factor this, I'd have to multiply the 3 and the 7, and that would be 21. And then I'd be looking for factors of 21 that added to be -2, and there aren't any. So if that won't factor, then we're just done. That's it. That's all of that one. Next one. Same idea here. Factor those denominators, come up with a common denominator, give your numerators whatever they're missing, and then simplify. And that's it. I'm going to kind of go sideways here just to save some space. This first denominator right here, I can actually factor out a 2 as a GCF of 2. That would leave me with x squared plus x minus 6. And then this second denominator, x squared minus 4, that's a difference of squares. So that would actually be x plus 2, x minus 2. And then we want to keep factoring as much as we can. And that part right there will factor some more. Two numbers that multiply would be -6, that'll add to be 1. Well, that would be plus 3 minus 2. So this one, I'm going down now. would be 2 times x plus 3, x minus 2. That 2 is the same as that 2, and I just factored that to be that. This one we've already factored, so it's good. X plus 2, x minus 2. All right, remember, common denominator needs every unique factor that exists in either denominator. So I'm going to come over here and do this, just so I got some room to go that way. I got a 2 there, I need a 2 in my common denominator. I got an x plus 3, I need an x plus 3 in my common denominator. I've got an x minus 2, I need an x minus 2 in my common denominator. I've got an x plus 2, I need that. I got an x minus 2, which I already have listed. Then you look and you make sure that nothing was squared or anything like that. You didn't have anything repeated in one single denominator. We don't, so this is good. This is the common denominator. Now, you're just giving both of those numerators whatever part of that denominator they were missing. So here's the 6 that's sitting right there. I got the 2, I got the x plus 3, I got the x minus 2. The only thing that I'm missing there is the x plus 2. So multiply that to the 6. Bring down the minus sign, bring down the 2. This one has the x plus 2 and the x minus 2, so it has both of these, so it's missing this part over here. So it's missing a 2, and it's missing the x plus 3. And now we're just simplifying. That first one becomes 6x plus 12. This would just be 4, so I'm distributing a negative 4 through there, so that would be minus 4x minus 12. Not doing anything to the denominator, it's already done. Just leaving it like that in case something ends up canceling in the end. Well, these 12s would just cancel. 6x minus 4x is 2x. And it's annoying to keep writing this denominator every time, but we need to. And then look at what happens. This is the only reason we keep it the way it is. Now I've got 2x in the numerator, I've got all this stuff in the denominator. These 2's would actually cancel. And so my final answer here, I'm gonna try to squeeze it in right here, x over x plus 3, x minus 2, x plus 2. It's JV, it's so easy. Okay, so this is the finale. And this one's ugly, I know. But it's not anything different. It's just bigger and uglier. It does combine a little bit of what we did in the previous section though, when we did the multiplying and dividing. So we're gonna have to recall some of that. So what you're dealing with here, and they call this a complex fraction, just means you got fractions inside of fractions. But if you look at it, there's really one big fraction. And in the big fraction, like this is the numerator and this is the denominator. And we learned how to divide fractions. Like we know how to do that. We even know how to do them with rational expressions. That was from the previous section. So what we have to do today though, is we have to make it look like one of those other problems that we previously did. And to do that, we got to do our common denominator stuff. So in the big numerator here, I'm just looking at these two denominators. I've got an m minus 3 and an m minus 4. So that would be my common denominator for these two fractions that are up here. The 16 would have to get multiplied by m minus 4, and the 4 would have to get multiplied by m minus 3. So that is just that. We'll do the same thing in the denominator. This one has an m squared and an m minus 3, so that would be the common denominator, m squared, m minus 3. The 16 needs the m minus 3, and the m minus 4 needs the m squared. All right, so we can just sort of clean this up a little bit. This would be 16m minus 64 minus 4m plus 12 over m minus 3, m minus 4 over 16m minus 48. And then here I'm actually distributing a negative m squared through there. So that would be minus m cubed plus 4m squared. over my common denominator, which was m squared times m minus 3. All right, we're almost there. Got some like terms there in that numerator of the numerator. Let me do this so indicate we're going this way. 16m minus 4m is 12m. Negative 64 plus 12 would be negative 52 over m minus 3, m minus 4 over, in the denominator, I've got negative m cubed, there was nothing to combine with that, plus 4m squared, plus 16m minus 48. So I really didn't even do anything but change the order of stuff. And that, of course, is over m squared times m minus 3. So now you've got a fraction over a fraction, which is what we dealt with in the previous section. We're just dividing two rational expressions here. And remember, when you divide fractions, you just multiply by the reciprocal. So this is 12m minus 52 over m minus 3, m minus 4, times the reciprocal of this guy, which would be m squared times m minus 3 over negative m cubed plus 4m squared minus 16m minus 48. Okay. Well, you know, we're looking at this as one big thing here. Remember, we can cancel anything that's in the numerator. Sorry. We can cancel anything that's in the, as long as something's in the numerator and in the denominator, it doesn't matter if it's in different fractions. So like I can cancel those m minus 3's there. And so that's the only thing that cancel. I'm left with m squared times 12m minus 52 over m minus 4 times negative m cubed plus 4m squared minus 16m minus 48. Nothing else cancels. We've combined everything. That's good enough.